Welcome back to my channel, YouTube. I am Sri Tips. This will be part 12 of the stock pot refining videos. And I'm ready for this thing to be done. I've been working on it for a long time now. And I've got some other videos that I'd like to do. But I want to get this one completed and out of the way before I jump in to the next few videos that I have planned. Just to give you a preview, what I've got here is I've got the some palladium from the stock pot earlier in this series. I can't even remember where this came from. I've got some platinum from this series, and I can't remember which video that came from, but we're going to refine that. This is some platinum salts that I got from videos a long time ago, maybe a year ago, that I've been hanging on to. This is the platinum salts from those previous videos, and I want to get this refined. I've got some platinum metal here that I rolled out real thin. This was some jewelry items, some rings and so forth, and I want to get this dissolved and get this refined. And then I've got a new, larger sulfuric acid stripping cell that I want to try out. I've got some gold-plated stuff here, and what I want to do is increase the volume of the sulfuric acid electrolyte and try to get a nice yield off of some of this gold-plated scrap that I have. And I've got a big bag of gold-filled scrap here that I've been accumulating, and I want to get that done and then offer the ingot of gold that comes from this for sale on my eBay store. But before I do all that, what I want to do is get this stock pot refining video series finished up, and I'm going to start on part 12 right now. Okay, we're going to start out by taking the large beaker here that has our ash in it, and I'm going to add the test batch that I segregated in the other video that I didn't use. I'll put this back in here. Now what I'll do is add the contents of this beaker here into this main batch here, because it's the same material. Give this a stir. Set it up here on some low heat. Now I'll measure out 800 ml of hydrochloric acid. It's 800 ml, this mark right here. Now I'll carefully pour the hydrochloric acid in with the ash. Got some concentrated nitric acid here, and what I'm going to do is measure out 130 ml in this cylinder here, And then we're going to slowly start adding that to our mixture in the beaker to extract the platinum group metals out of there. Now I'll add about 20 ml or so of the concentrated nitric acid to the beaker. And now I will give it a quick stir here. Sure how this is going to react. It probably will not be that vigorous, but I'm going to add about another 40 ml of the nitric here, stir it up, and then we'll let that cook for a while. Down in the beaker here with a piece of filter paper on the end of a bamboo skewer, and we're going to do a stannous chloride test here. We've got an orange color going on there, which indicates platinum. It doesn't look like there's a whole lot in there. This has been on about medium heat now for about an hour and a half. I'm going to go ahead and add the rest of the concentrated nitric acid here. There's about 60 ml left. Want to boil the solution over. Still got about 40 ml of concentrated nitric left to go in. And just to show you this stannous test right here, that's what the stannous chloride test is looking like. It's been on the heat now for about 2 hours. I'm gonna go ahead and get a temperature reading on it. Got 168 Fahrenheit, 75.8 Celsius. Try to get this last bit of nitric in there, about 40 ml to go here. I'm going to add it real slow. Give it a gentle stir, and we'll leave this on to cook for several hours. It's been on now for just over 3 hours. I'm going to pull the lid lid off here, stir it up. I'm going to let this go until all them fumes disappear. I got it on about a medium heat here. Been on the heat now for about, it's like 16 hours. I've let it simmer. I've reduced the volume by a few hundred ml. I'm going to pull it off the heat now, let it cool down, and we'll retrieve the liquid and go from there. Transfer the solution into a tall beaker back here, and this will help with getting the solids to settle out of that liquid, and we can get the liquid off easier if it's in a tall beaker. Got the solution allowed to settle. It's been settling now for several hours. I'm going to get some of the solution into a pipette here. I'm going to put some drops in this spot plate. 1, 2, 3, 4, 5. Now I'm going to do some tests on the solution here. See what we got in solution. First off is some stannous chloride, freshly prepared on 13 February. And as you can see, I got an orange reaction here, which is an indication that I have platinum in solution. Probably a little bit of palladium as well. Now in this cavity, I've got some 10% household ammonia from the grocery store. What I'm going to do is I'm going to put the ammonia in this cavity right here on some of my solution. And you see that blue color, that means copper. So I definitely got copper in solution with the platinum and the palladium. Here I've got a little bit of DMG. And what I'm going to do is add some DMG to this cavity. And I get a little bit of a bluish green precipitate there. I'm not quite sure what that is. And then lastly, I've got a piece of zinc in this tube here. And I'm going to add some of our solution to this. And you can see as soon as the solution hits the zinc, it begins reacting. I'm going to turn my fan on here. Based on these test results, I've got platinum and palladium in solution. This is the stannous chloride. This is the ammonia. It turned blue, which means I've got copper in solution. This is the DMG. It's got a greenish, dark green precipitate down in the bottom there with some orange material left around it, which is probably platinum in solution. And I didn't do anything with this one. This is just a blank spot. And then here I've got zinc. You can see copper coming out of solution on that zinc. I can see red copper metal coming out of solution on that zinc. But it's also bringing the other metals out of solution. Doing it pretty good, the black powder. But this is going to be full of zinc. Or not zinc, it's going to be full of copper along with the precious metals that are coming out of solution there. Up here, I've got some of the solution in with a few pieces of copper. In this third cavity, I put some DMG and I got some precipitate that fell to the bottom of the cavity. I'm going to get a little bit of the solution that's left around it on this piece of filter paper here. And I'm going to test that with some stannous. And I can see a faint orange stain there. Now I'm going to do another stannous test on the solution that doesn't have anything. It's just the bare solution right out of the beaker here. Put some stannous on that and see where we are with that. And you can see there's quite a different stain from the one out of the DMG. This is much darker up here, indicating that that DMG took some of the metal out of solution in cavity number 3 down here. It's much lighter. Alright, based on these tests, I think I got one of 2 ways to go here. See the copper coming out of solution there on the zinc? So this is going to be a black powder, but it'll be heavily contaminated with metallic copper. You can see the copper right in there. But this is possibly a way to go here. The other way to go is maybe use DMG to precipitate the palladium out of here. And but I don't know if that'll work either, because it looks like there's going to be some copper in with that precipitate since it's green. The copper up here, using metallic copper, the thought there is that it will cement out the precious metals, but it won't cement out the copper. It'll leave that in solution. But I don't think the copper is going to be reactive enough. It would take too long. It'd be too slow of a process. I'd be right back where I started. With black PGM powders in a copper solution. I don't think this is the way to go here. This is some of the solution out of this beaker with some pieces of copper wire in it, just to see what would happen. And copper's not reactive enough. I think that's going to take too long. You can see the metals coming out of solution on the copper. They've turned black. Here's another look at the stannous tests. This one was from the solution out of cavity number 3 here from the DMG test. It's got just a faint trace of orange there. This one was from the cavity that had just the solution out of the beaker here. And it's got a nice green and orange stain. Okay, here's a list of the reactivity series of metals, and based on the tests out there, I've got some platinum, some palladium that's not shown on here, but it'll be down here with the platinum. I've got platinum, palladium, and copper in solution. So what I'm thinking is use copper to cement out the platinum and palladium. But that's not a good way to go, I don't believe, because copper's way down the list down here. It's not very reactive, and it would take a long time to cement those metals out. That's the same thing would be happening there as what happens in my stock pot. The other way to go is I used a piece of zinc, which is way up here on the list. Zinc is much more reactive. You've seen as soon as I put the solution from the beaker in on top of that piece of zinc, it immediately began to react. That's because it's higher up in the series and more reactive. Copper's less reactive. So the way I'm thinking of going here is just go ahead, cement everything out on zinc, and then get everything as a black powder from the zinc cementation process, and then process the black powder from that point. It's going to be full of copper because the copper is cementing. Copper's down here below zinc, so anything below zinc that's in that solution is going to cement out and contaminate whatever solid material I get out of the cementation process with zinc. I think I'm going to stop the video right here and issue an appeal to my viewers. I am at the same spot I was when I first started. I've got platinum, palladium, and copper in solution, and I'm not sure how to proceed here. What I did last time was I just cemented everything on the zinc and then went from there, and I'm thinking that's probably the way to go here. But as you've seen from the tests that I performed, when I put that solution on that piece of zinc, I got some black powders coming out, but I also had lots of copper precipitating out on the zinc, which is going to contaminate my black powders. The other way to go would be to try to cement everything out on copper, because the copper that's in the solution won't cement out on copper. It'll stay in solution. But then I'll be right back where I started with platinum group metals, mixed black powder platinum group metals in a solution of copper. The third alternative, based on those tests out there, would be to add some DMG to the solution. I still got to filter it. I will filter the solution out before I process it any further. But I could add some DMG and get the platinum group metals to drop with the DMG. But based on that test out there, I've seen some green precipitate in the DMG test, which tells me that copper is also precipitating out. So it just drags the copper right with it, it appears. So if you more experienced viewers are watching here, I'm talking Geo, Goran, Lou, Rick, Four Metals, if you guys have any kind of way to get that copper out of there before I cement the platinum group metals on the zinc, let me know in the comment section how to proceed here. I guess that will conclude the video. Part 12 is done now. I'm going to wait, see what kind of response I get here before I proceed. My choice is just cement everything out on the zinc and then refine it from there. It's going to be heavily contaminated with copper, but I think that's my choice. That's what I think I'm going to have to do here. But I would love to hear from the more experienced refiners if there's any input from them. That'll conclude the video. Thanks for watching.